Hey guys, this is Christian, and today I want to talk about Ethernet cables, the technology that we're using to connect computers, servers, and other networking equipment to transmit data. Because if you're building a home lab or experimenting with IT stuff, a solid and reliable networking setup is key. And finding the right equipment isn't always easy. Most people don't think carefully enough about the different standards and specs of Ethernet cables. But don't worry, in this video I'll tell you everything you need to know. Let's unveil all the magic behind Ethernet cables, and at the end I promise you to have much more clarity about which ones might be the best for your home lab setup, so you can make a solid decision which ones you're gonna buy. But before we start, I quickly would like to show you NetBird, a zero configuration VPN that helps you securely access your network from outside. Thanks NetBird for supporting this video. It's really an interesting tool for us home lab people because it's free and open source, so you can self-host it completely. However, today I'd also like to highlight the cloud version of NetBird, which you can also use entirely for free to instantly get started. And that's, by the way, the same version that I'm currently using myself in my home lab. It doesn't require any server installation at all, but still gives you the ability to transmit data securely between all your devices. It's using WireGuard in the backend, which creates high-performance peer-to-peer tunnels. And the best thing, you can also create granular access control rules where you can decide which groups can access which protocols and ports on your local devices. That is really amazing. You also don't need to open any ports on your firewall, it just magically works. And if you are interested in using NetBird, maybe for professional production setup, and you want to use some advanced features like multi-factor authentication or integrations with EDR solutions or device posture checks, you can use my promo code ChristianLemper to get 20% off all the teams and business plans of NetBird. That's a great opportunity to upgrade your network security, so check it out. I'll leave you a link in the description down below. Okay, let's go back to Ethernet cables. I bet you have already seen something like this, yeah? This is a typical copper Ethernet cable which we use every day in IT to connect computers and servers or maybe other networking devices like switches, access points. I hope you're quite familiar with it. Ethernet cables transmit the data between all those devices in a network. They carry the electrical signals representing the binary code that computers and network devices use to communicate. And if you are not into networking, you probably haven't thought about the specs of a regular Ethernet cable yet, because most of the time it just works out of the box. Yeah, everything here is strictly standardized, and since every device that has a connector like this speaks the same standards, it's all made to be less complicated. You just plug it into your computer and into your switch or router, and it just all works. However, if you're planning a more professional networking setup for your home lab, you will notice that there are a few important differences between all these standards and cables that are existing, and it's worth taking a closer look at those to decide which ones might be a good fit for your setup. Just to tell you briefly about my background, so I've been working in professional IT services for many years, and I've also been on site to a couple of customer setups, working with networking equipment and so on, and we've always used high quality industry standard Ethernet cables. However, when building a home lab scenario, there are maybe other factors to take in consideration, such as investment cost, for example. Yeah, you don't want to make it too expensive and you want to keep it simple at some level. But at the same time, it should also be future-proof enough. For example, if you want to upgrade your NAS connection to your server to 10 gigabit at some day, your Ethernet cable should of course support that high throughput. And in the worst case, you can lose a lot of money, and of course it causes a lot of headaches if you're making the wrong decisions in the first place. Firstly, let's discuss a few basics, so to get everybody on the same page. If you open an Ethernet cable, inside the protective outer jacket, Ethernet cables have typically 4 pairs of wires, making 8 wires in total. And each pair is twisted together to help reduce interference and maintain a more reliable connection. The wires within each pair are color-coded to help identify which wires go together and to maintain consistency during an installation and troubleshooting. And they usually come with an RJ45 connector at each end, so something like this here, which you can plug into any networking hardware And you get those cables in all sorts of colors, lengths, and quality levels. To know exactly which of the color-coded wires has to be in which place on an RJ45 connector, there are two types of standards defined for a straight-through twisted pair Ethernet cable. The first standard is the T568A standard, so this defines that the first wire should be the white-green one, the second the green, the third the white-orange, then the blue, the white-blue, orange, and so on. There's also a second standard around, the T568B standard. As you can see, this is very similar to the first one, but the white-orange and the orange wires are basically switched with the white-green and green wires. Just to let you know, there's also another standard existing, which is called a crossover twisted pair Ethernet cable. And this is kind of a weird one because it's an older standard that was used back in the days when the networking devices weren't able to send and receive data through the same wire. So for example, if you wanted to connect one computer with a second computer and both would try to send data through the same wire, that would cause problems. So this is why back in the older days we used crossover cables. So the first computer would send the data on the same wire as the second computer, but because inside the cable those wires are crossed over, the data arrives at the expected wire on the second computer. Now, those crossover cables can exist for both standards, so the T568B and A standards, but as I said, they aren't really used anymore. Just if you see a crossover Ethernet cable, you can basically ignore them, but just for your background so you know what you're talking about. Knowing those standards is really important because if you want to route Ethernet cables over longer distances or connect multiple devices together across different rooms, you will likely also want to cut those cables and use other networking equipment to extend the connection, such as Ethernet jacks, for example, or connect RJ45 connectors yourself directly to the cable. These you can simply use with any other networking equipment. You just plug in the RJ45 connector to the Ethernet jack. And of course, when you're building even more professional networking setups, you will also want to use patch panels, for example. This is what you typically find in any server or networking rack, but they are also very useful in bigger home labs to better organize your networking setup. To use those patch panels, you just connect the wires of your Ethernet cable with the right corresponding ports on the patch panel, and those two standards, the T568A and B standards, help you to know which wire to connect in which place. Just as a side note, it's not really important which of those two standards you're using. If you're using patch panels and Ethernet jacks, you can decide on your own if you want to follow the T568A or B standard. As I'm familiar with in Germany, the A standard is quite common, but in other countries it might be different. For example, in the US, I heard that the B standard is what most people are actually using. But in the end, it really doesn't matter. The only thing that you need to consider is you should never mix those two standards. So for example, if you have one Ethernet jack in the first room and in the second room, the corresponding Ethernet cable is using the different standard, so then you might run into problems. So first of all, just decide which standard you want to follow, and then consequently use the same standard across the entire setup. So this is the first important thing to remember if you want to build a more professional networking setup at home, especially if you want to use patch panels and Ethernet jacks, is to know so which of the color-coded wires has to be in which place and which standard to follow. However, if you're searching for those type of equipments, you will notice that there are also many other different Ethernet standards around, especially for the quality levels of an Ethernet cable. Ethernet cables are categorized based on their specifications and capabilities, such as their maximum data rate and maximum transmission distance. Some of these common categories include Cat5e, Cat6, Cat6a, Cat7 and 8, with higher numbers indicating better performance and newer technology. And just to let you know, there are also lower standards existing, but I haven't really mentioned them as they are not relevant anymore. These were used back in the old days when 1 gigabit wasn't even the standard. By the way, I still remember that time, yeah, because it took me a long time to convince my father to upgrade our home network, because he still believed a few years ago that 100 Mbit should be enough for most networking devices, but I wanted to play online games without any lags and problems. So I wanted to upgrade our setup to be able to use 1 gigabit per second. But yeah, luckily these days are over now, and now I have my own professional networking setup with a bit more maximum data rate possible. But yeah, there are still some environments where Cat5e is still around, yeah, because it's very cheap. But honestly, I wouldn't bother with it anymore. As I said, it only supports up to 1 gigabit per second, which is still probably the highest data rate the vast majority of networking devices support. So most of the lower end computers, any access points, routers, they will likely just go up to 1 gigabit per second. So you could argue that this would be enough for the vast majority, but you also need to take in consideration that some modern gaming mainboards, for example, so most of the modern hardware equipment already is specified for 2.5 gigabit per second, so I would not really use Cat5e anymore these days. So better go with the Cat6 cable, which is also specified for 1 gigabit per second, but as it increased the maximum frequency to 250 megahertz, so this is able to get even 10 gigabit through it. Probably not over the maximum cable lengths, because this Cat6 is only specified for 1 gigabit per second over 100 meters. And this is really like operating at the edge of the cable's capabilities. So you can get 10 gigabit connections through this cable, but approximately only over 55 meters in the best possible conditions. So there might be scenarios where Cat6 is not working with 10 gigabit, yeah, especially if the cable is longer. So then you probably should better switch to a Cat6a cable. And this is then really specified for 10 gigabit per second over 100 meters. It even doubled the frequency to 500 megahertz. And this is definitely enough to get this data rate reliably through that cable over 100 meters. So one thing that I haven't mentioned yet is, as you can see, there is a shielding options for all those cables. And category 5E up to 6A have two options for shieldings. Yeah, it can be as an unshielded or as a shielded cable. Now, with the newer standard, the Cat7, once that was introduced, this cable is now also using 10 gigabit per second, and they also increased the frequency up to 600 megahertz a bit, but this is now only available as a shielded option. And also the next standard, which is even higher, the Cat8 standard, this is then specified for 25 to 40 gigabit per second. It even increased the maximum frequency even more to 2000 megahertz. But this is only specified for cable lengths up to 30 meters. So this is really a very special condition when you would use a Cat8 cable. So maybe in data centers, or yeah, when you want to connect some devices over copper cables where you really need high throughputs, such as when you're connecting two core switches together, for example. I wouldn't use Cat8 in a Homelab scenario. This is just too much, and yeah, honestly, there are better options for connecting core switches or get high data through cables that is even cheaper. That, for example, is obviously fiber optical cables. But yeah, we will talk about this in another video. In this one, we will focus just on copper Ethernet cables. Now let's talk about this shielding. What is it and why do we even need it? So as we have seen, with each higher category of Ethernet cables, the frequencies have been increased just to get more data through the same wire. But that introduced some technical problems. Yeah, for example, EMI, which is electromagnetic interference, and RFI, radio frequency interference. And I don't want to get in those physics here, but with higher frequencies, you can say we have more interference. And that's why higher quality cables use different types of shielding to overcome these problems. For example, this is a Cat7 Ethernet cable. As you can see, the cable has a metal braid around the twisted pairs of wires, and each twisted pair is covered by an aluminium foil, which is sometimes a bit hard to get off, especially when you need to patch those cables. But both techniques can be used either separate, so just only a braid or only a foil, or you can use them both in combination. Of course, both at the same time. This provides you the best protection against EMI and RFI, but you also sometimes find types of cables with either just a braid or just a foil. So this table shows you the most commonly used types of shielding. I don't want to get in all of the details here. Maybe I'll make a separate video or a course about networking. So if you want to see that, please leave me a comment. So then it's important to know all these differences, yeah? But in a Homelab, you just need to remember that there are different types of shieldings existing, and they usually get better the higher the category standard of the Ethernet cable is. So high quality categories like Cat 7 and Cat 8 usually always come with a foil and a braid, which is called an SFTP standard. So this is what I've shown you in the short video clip, for example. Older categories like Cat 5e, Cat 6, and Cat 6a, you sometimes get with or without a shielding option. So unshielded types of cables are usually called UDP cables. And then you also got those, weird option with either just a braided shield or just a foil shield. So taking in consideration that EMI and RFI can cause problems, you will probably say, well, it's an easy decision, yeah? Just pick the best quality and you won't have any problems in the future. But it's not that easy, because there are a few downsides with shielding. First, because it just costs a lot more. Because there are materials that are used for the braid and the foil that just need to be paid by someone. And the next problem is that shielded cables are usually a lot thicker than unshielded cables. For example, this one here is a Cat 7 SFTP cable compared to a Cat 6 UTP cable, and you can clearly see the difference. Also, because the foil and the braid are used in these Cat 7 cables, those ones are usually much harder to bend, which can be an issue if you need to get them routed through a small hole in the wall or ceiling, especially when routing many cables across your house. Doing this all with Cat 7 shielded cables is the absolute hell, I can definitely tell you that. But the most problematic thing is that shielded cables need to be always grounded properly. Without grounding, the shield inside the cable can act like an antenna, so it picks up more interference. So that basically means if you don't connect the shield correctly, it doesn't protect you from interference, it will do the opposite, it will even make it worse. It's important to mention when you're just connecting two devices with a shielded cable that already has two RJ45 connectors on both ends, you usually don't need to take care about this. But when you're using patch panels or connect these with Ethernet jacks, you need to take care that you ground them properly, so consequently all the networking equipment you want to use in between those devices needs to be shielded and grounded as well. Otherwise, you might get problems with interference, which can drastically decrease your network performance and throughput. For example, I once had a situation where I was using a Cat 7 cable, and on the patch panel, the connection was grounded properly, but on the Ethernet jack, the shield wasn't connected to the metal cover of the Ethernet jack. And what that caused was I was only able to get 100 Mbit through this Cat 7 cable, so really much less that you would get with a lower quality standard. And if you don't feel comfortable with that, I mean, it's not that complicated to connect the shielding and ground all your equipment, but I can totally understand why somebody doesn't want to bother with that, yeah? And then you can save yourself so many headaches and money, by the way, if you just use unshielded Ethernet cable, so Cat 6 or Cat 6a. So what can we learn from all this? Yeah, we've discussed all the different category standards, the shielding. There's still the question around what should you buy? And let's go back and take an objective look at what we want to achieve in a Homelab scenario. So in a Homelab, we mostly operate on 1, maybe 2.5 gigabit speeds, maybe 10 gigabit in certain scenarios, but it's definitely not the vast majority. And based on these category specs we've talked about, to support our scenario, we need at least a Cat 6 cable, better a Cat 6a if you can get it, or a Cat 7 would be perfect, but this is only available as an SFTP shielded version. So it basically comes down to a decision between one cheaper and simpler option by using an unshielded Cat 6 or Cat 6a cable versus the industry standard, which is you would go with a Cat 7 cable if you want a really solid setup and you feel comfortable with shielding and grounding all your other networking equipment like patch panels, Ethernet jacks, and so forth. Just my honest and humble opinion, for most setups, an unshielded Cat6 or Cat6a cable will be totally fine. For example, I'm using myself an unshielded Cat6 patch panel in my server rack, and all the cables are Cat6, so they support up to 10 gigabit because they're not longer than 55 meters. And this is really a great option and a solid networking setup for the vast majority of home labs. However, if you want more reliability and you want to do it the right way, just like you would do it in a professional industry setup, you have to go with a Cat7 cable, in my opinion. There's no reason to go with a higher standard like Cat8 in a home lab, because let's be honest, I can't think of any reason why anyone should pick a Cat8 cable for a home lab setup, but Cat7, that's definitely the recommended option if you want to get the best of the best and you want to get a high quality networking setup. So in the end, it's up to you, but these are the two best options that you can choose, just to say you're not doing anything wrong when using one of them. So I hope you now got a bit more clarity about the different types of Ethernet cables, the quality standards and shielding options. If you find this useful, then it would be so cool if you could just like the video and subscribe to the channel. And if you want to get more resources, you want to get more content, then why not join our awesome community on Patreon? So there I'm creating many more stuff for you guys. And yeah, thanks to all the supporters on Patreon. You guys are just amazing. And thanks everybody for watching. I will catch you in the next tutorial. Take care. Bye bye.